Students, I'm Mrs.Sweetly, Assistant Professor in Civil Engineering Department, working in Emmanuel RSJJ College of Engineering. Today we are going to study about the moment of inertia concept. If you want to know about the moment of inertia, first of all we want to know what is meant by centroid. Centroid is the geometric center or center of gravity of two-dimensional object representing the average position of all points within it. Do you understand? Centroid is nothing but we are locating the point as center for an object both in x-axis as well as y-axis. It is represented by capital G. If we consider one object, we have to locate the centroid point G by considering the object in both x-axis as well as in y-axis. The centroid value becomes different based on the shape of the object. Now we are going to study some formulas for centroid of simple plane figures. First of all, square. What is meant by square? Square have the four equal sides. Here we are considering a square of side small a. Okay, four sides are equal. If we are going to calculate the x bar and y bar value, x bar represents the centroid along x-axis and y bar represents the centroid along y-axis. For square, both x bar and y bar are equal. The value is equal to a by 2 because all the four sides are equal. Therefore, the formula is a by 2. Then area formula, we know that area of square is a square. Then second shape is rectangle. What is meant by rectangle? If opposite sides are equal, then the shape is said to be rectangle. Here, we are considered the rectangle of length L and width B. Therefore, x bar value, the centroid value along x-axis is equal to L by 2 and y bar value is equal to B by 2. Then we know that area of rectangle is length into breadth. Next shape is isosceles triangle. Consider a triangle of base width small b and height small h. The centroid value along x-axis is x bar is equal to b by 2 and y bar is equal to h by 2. Area of triangle is half bh. Then consider a right angle triangle, which means 90-degree angle on one side. The value for x bar is b by 3 and y bar value is h by 3. Then area of triangle is same, half bh. Then we considering a circle. Okay, fifth shape is circle. The x bar and y bar value remain same for circle and the value or formula is d by 2 and the area of circle formula is pi d square by 4 or pi r square. Here d represents the diameter of a circle and small r represents the radius of the circle. Next, sixth shape is semicircle. Here we are considering a semicircle which is resting along the x-axis. Okay, therefore x bar value is d by 2 and y bar value is 4 or by 3 pi. Then it is a semicircle. Semicircle means half of the circle. Therefore, the area formula becomes half of area of circle, that is half pi d square by 4 or half pi r square. Next, we are considering a semicircle which is resting along y-axis. Therefore, the formula gets interchanged. The formula for x bar becomes 4r by 3 pi and y bar becomes d by 2. Then area formula is same. Half of the area of circle. Half pi d square by 4 or half pi r square. Then we are taking a quadrant. Quadrant means half of semicircle or 1 by 4th part of circle. And here the formula for x bar and y bar remains same and is equal to 4 or by 3 pi. Then the area formula becomes 1 by 4th times of area of circle, which means 1 by 4 pi d square by 4 or 1 by 4 pi r square. Here I give some important formulas only. There are many other formulas for different shapes like trapezoid, parabola, etc. If we want to find the center of those shapes, we have to study those formulas also. Okay. Now we are going to moving towards the moment of inertia portion. What is meant by moment of inertia? Moment of inertia is nothing but it is a measure of object's resistance to changes in its rotational motion. It is denoted by capital I and its unit is millimeter power 4 or meter power 4 or centimeter power 4. Any other units, unit power 4. It is also known as rotational inertia or angular mass. Moment of inertia is the resistance of an object to withstand its rotational motion. Okay, is it clear? Moment of inertia is the resistance of an object to withstand its rotational motion. Now we are going to study some moment of inertia formulas for simple plane figure. First we are taking the rectangular portion of width b and height h. The formula varies based on the direction, x-axis or y-axis. The moment of inertia of rectangle along x-axis is given by Ixx is equal to bh cube divided by 12, and the moment of inertia of rectangle along y-axis is Iyy is equal to hb cube divided by 12. Here b represents the width of the rectangle and h represents the height of the rectangle. Then second shape, we are considering a hollow rectangle section. What is meant by hollow section? If we cut one portion from the solid section, then that shape is known as hollow section. Here from one solid rectangular portion, another one rectangular portion is cut and removed. Therefore, the section remain hollow. Here we are considering a rectangular portion of outer diameter capital B and height capital H. Therefore, inner rectangle is of the dimension small b and small h. Then the value for Ixx is equal to 1 by 12 capital B h cube minus small b h cube. Iyy is equal to 1 by 12 capital HB cube minus small hb cube. Here capital B and capital H belongs to the width and height of the outer rectangular section, and small b and small h represents the width and height of the inner rectangular portion. Then third shape is square. Already we know that square have 4 equal sides. Here we are considering a square of side A. Therefore, the value for Ixx and Iyy remains same. The moment of inertia along x axis and y axis for a square is equal to a power 4 divided by 12. Here a represents the side of the square. Then fourth one is hollow square. Here from one solid square, another one square portions is cut and removed. Therefore, it remains hollow. Therefore, the outer square is of dimension capital A and the inner square is of side small a. Therefore, the formula for Ixx and Iyy remains same for the square and is equal to 1 by 12 capital A power 4 minus small a power 4. Then fifth section is triangular section. Triangle. The formula for triangle, Ixx for triangle, which means the moment of inertia along xx axis for triangle is bh cube divided by 36 and IYY for triangle is HB cube divided by 48. Then we are moving towards the product of inertia. What is meant by product of inertia? Product of inertia is obtained by multiplying each elementary area dA by its coordinates x and y and integrated over the area A. Okay, product of inertia is represented by capital IXY. Its unit is also unit power 4. If the values are given in millimeter, then millimeter power 4. So how we obtain the product of inertia? We obtain the product of inertia by multiplying. Okay, with the product represents the multiplication. Therefore, multiplying the elementary area dA by its coordinates x and y. Therefore, in product of inertia, we want to know the coordinates. I hope all of you know how to draw the graph. How many quadrants are there in a graph? There are 4 quadrants. First quadrant, second quadrant and third quadrant, fourth quadrant. In the first quadrant, both x-axis and y-axis are positive. In the second quadrant, x-axis is negative and y-axis is positive. In the third quadrant, both x and y-axis values are negative. In the fourth quadrant, x-axis value is positive and y-axis value is negative. Here, in the first quadrant, we are considering a point or section in a first quadrant. Therefore, we represent the coordinates as x1 dash comma y1 dash. Both values are positive in first quadrant. Okay, while representing the product of inertia coordinates, you have to represent it as dash, x1 dash or x2 dash. Something like that you have to represent. Okay, dash represents the product of inertia coordinates. Okay, is it clear? You have to mention the dash properly. In the second quadrant, if we are considering one section in the second quadrant, then the x-axis value is negative and y-axis value is positive. Therefore, minus x2 dash comma y2 dash. In the third quadrant, minus x3 dash minus y3 dash. In the second quadrant, the value x-axis value is negative and y-axis value is positive. The third quadrant, both the x-axis value and y-axis values are negative. Then for the fourth quadrant, x-axis value is positive and y-axis value is negative. Next, if we analyze the composite section, then we want to know about the parallel axis theorem. Okay, what is meant by composite section? Any of you know? Yeah, composite section is nothing but when two or more sections are combined together, then the section is known as composite section. Okay. Therefore, if you want to analyze the composite section and find the product of inertia or moment of inertia, then we have to use this parallel axis theorem. The parallel axis theorem states that the moment of inertia of a body about any axis is the sum of its moment of inertia about a parallel axis passing through its center of mass Ig and the product of its mass A and the square of the perpendicular distance h bar between the axes. How we find the Ig, h bar and A? Is there any idea? Ig is nothing but the moment of inertia formula for each shape. If it is a rectangle, then the formula for Ig is bh cube divided by 12. Same like that area for that corresponding section. If the section is rectangle, then the area of rectangle is L into B, length into width. Then here h bar represents the square of the perpendicular distance between them. Okay, the h bar formula remains. While calculating Ixx, you have to use h bar is equal to y bar minus y1 or y2, etc. While calculating for y axis, Iyy is equal to Ig plus a h bar square. Here h bar formula becomes x bar minus x1, x2, etc. Next one is we are going to know about the product of inertia. We already studied about the product of inertia. It is represented by Ixy. Ixy is equal to integral over a xy into dA. Then next one is principal moment of inertia. Principal moment of inertia is represented by I maximum or I UU, comma I minimum or IVV. Then we want to know about the principal moment of inertia. Principal moment of inertia is I maximum and I minimum. It is also represented as IUU and IVV. The formula is I maximum or IUU is equal to IXX plus IYY by 2 plus root of IXX minus IYY by 2 the whole square plus IXY the whole square. Then for I minimum or IVV is equal to IXX plus IYY by 2 plus minus root of Ixx plus Iyy by 2 the whole square plus Iyxy the whole square. Then if you want to locate the principal axis, then the formula is tan 2 theta is equal to minus 2 Ixy divided by Ixx minus Iyy. From that we get the answer for 2 theta. First 2 theta is equal to tan inverse minus 2 Ixy divided by Ixx minus Iyy. From that we have to calculate the value for theta. Therefore theta is equal to the value divided by 2. Okay, principal moment of inertia is nothing but finding the moment of inertia about the principal axis. Okay. Now I am going to explain one problem. Okay, the question is locate the principal axis and determine the principal moment of inertia of an angle section shown in figure. What is meant by angle section? If two rectangular portions are connected together in a form of L, then that section is known as angle section. Okay, here they asked to find out the principal moment of inertia and locate the principal axis. Okay, here the L portion or angle section is divided into two rectangular sections of dimension. First rectangle is of dimension width 80 mm and height 20 mm or length 80 mm and width 20 mm. Okay, then the second rectangular portion is of length 20 mm and height 80 mm. Okay, the total height is 100 mm. You have to reduce the 20 mm. Okay, then first we are going to find out the centroid. Okay, here we have two rectangular sections. Therefore, the formula is x bar is equal to a1 x1 plus a2 x2 divided by a1 plus a2 and y bar is a1 y1 plus a2 y2 divided by a1 plus a2. If we have three sections, then formula becomes x bar is equal to a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3. Okay, here the first rectangular component is of dimension 80 mm cross 20 mm. Therefore, what is the area formula for rectangle? Length into width or width into height. Here the length value is 80, then width value is 20. Therefore, 80 into 20 value is 1600 mm square. Then formula for x bar and y bar of rectangle is x bar for rectangle is L by 2. Okay, 80 divided by 2 and y bar is b by 2, that is 20 divided by 2 is equal to 10 mm. Then for component 2, here the first rectangular component is resting on the x-axis, therefore, and it is resting on the origin itself. Okay, it is present in the horizontal axis. Then the component 2, 20 mm cross 80 mm rectangular component is present. The area of rectangle L into B, therefore 20 into 80,600. Then x value, x bar value, the second component is resting on the y axis. Okay, it does not move away from the y axis. Therefore, the value or formula becomes L by 2, 20 divided by 2 is equal to 10 mm. But while taking the centroid for the second component, the second rectangular portion is 20 mm above the reference axis, okay, above the horizontal axis. Therefore, you have to include the 20 mm also, okay. Therefore, 20 mm plus formula b by 2, that is the b value is 80 divided by 2. Therefore, 20 plus 80 by 2. You have to consider the 20 mm also, okay. The second section or the second portion, rectangular portion, is 20 mm above the reference line, okay. Then substitute the values in the formula. You get the value for x bar and y bar. For x bar value is 25 mm, okay. I hope all of you know the substitution. Okay, already we find out the a1, x1, y1, a2, x2, y2 values. Okay, you have to substitute the values in a formula and put it in a calculator. You get the answer. Okay, the value for x bar is 25 mm and the value for y bar is 35 mm. Then next, we are going to find out the product of inertia coordinates. Okay, how we calculate the coordinates? Here we have two components. Okay, both are rectangular components. First, we have to find in which quadrant our component is present. Okay, therefore, for that we have to locate the centroid in our diagram. Here, the figure 14.25 shows the location of centroid. We obtain the value for x bar as 25 mm and y bar as 35 mm. Therefore, we locate the centroid G in the angle section. Okay, already the component 2 is of length 20 mm. Therefore, x bar value is 5 mm beyond the second component. Same like that, y bar value is 35 mm. Therefore, you have to mark the dimension of y bar in the y direction. Okay, we already have the height or width of 20 mm. Thus, we locate the centroid of the composite section. Then we have to find the center point of each component. Okay, here the first component, the length value is 80 mm and height value is or width value is 20 mm. Therefore, where we locate the centroid, which means L by 2 and B by 2. The L by 2 value is 40 mm and B by 2 value is 10 mm. Therefore, it comes along the fourth quadrant. Okay, the value comes in the fourth quadrant. Therefore, in the fourth quadrant, x-axis sign is positive and y-axis sign is negative. Then we are calculating the centroid for the second component. For the second component, the length value is 20 mm and width value is 80 mm. Therefore, the centroid value comes in which quadrant? Just identify, try to identify where it comes. You have to locate the G2. Okay, centroid for the second component, G2. The centroid of the second component comes under which quadrant? Second quadrant. Okay, the value is 40 and 10. We already locate the centroid. Therefore, the coordinates of G2 is under the second quadrant. Here the x-axis value is negative and y-axis value is positive. Based on that, we are going to find out the coordinates. The first component comes under the fourth quadrant. Therefore, x value is positive and y value is negative. Okay, x1 dash value is equal to plus x1 minus x bar. Okay, you have to write the formula as difference. Therefore, you have to subtract the greater from smaller. Okay, otherwise the formulas get changed. For y1 dash, the value is negative minus, here the greater value is y bar value is greater when compared to y1. Therefore, we are writing the y bar in first, y bar minus y1, or otherwise you write it as y1 difference y bar. Okay, you have to subtract the smaller one from the greatest. Okay, you get the value for y1 dash is minus 25 mm. Then for second component, second rectangular component, x2 dash, it comes under the fourth quadrant. Okay, therefore x-axis value is negative and y-axis value is positive, minus x2 difference x bar. Here the x bar value is greater, therefore we write it as x bar minus x2. X bar value is 25 and x2 value is 10. While subtracting, we get the answer as minus 15 mm. Then y2 dash is equal to y2 minus y bar. Here the sign is positive. Okay, in the fourth quadrant, in the y direction, the sign is positive. Therefore, y2 minus y dash. Sorry, in the second quadrant. Okay, here the component 2 is in the second quadrant. Therefore, the value is positive. Y-axis is positive plus y2 difference y bar. Okay, here the value of y2 is greater. Therefore, y2 minus y bar. The value 60 minus 35 is equal to 25 mm. Then we are going to find out the product of inertia. Product of inertia with respect to the centroidal axis. Okay, Ixy is equal to summation of a x dash y dash. Here we have two components. Therefore, we have to add the both components values. a1 x1 dash y1 dash plus a2 x2 dash y2 dash. We already find out the coordinates for x1 y1. Okay, x1 dash and y1 dash we already obtained the values. x2 dash and y2 dash also we obtained the value. How to substitute the values here? You get the product of inertia value Ixy is equal to minus 12 into 10 power 5 mm power 4. Then we are going to find out the moment of inertia. Here we have two sections. We have to find the moment of inertia about x-axis as well as moment of inertia about y-axis. While taking the moment of inertia about x-axis, we have two sections. Therefore, Ixx is equal to Ix1 plus Ix2. Ix1 is equal to Ig1 plus A1 h bar square, h1 bar square. This formula is from parallel axis theorem. Okay. Then Ig formula for rectangle is b h cube divided by 12 plus A1 we already find, b into h bar value formula y bar minus y1. Okay, y bar difference y1. Okay, you have to subtract the greater from smaller. Substitute the value, you get the answer for Ix1. The unit for moment of inertia is unit per 4. Here the value is given is in mm, therefore mm per 4. Then considering the moment of inertia for the second component, therefore Ix2 is equal to Ig2 plus A2 h2 bar square. Ig2 is equal to b2 h2 cube divided by 12 plus A2 into, here the h2 bar value is y bar minus y2. Substitute the value for Ig2, which means b h cube divided by 12 plus b2 h2 into y bar minus y2. You obtain the value in mm per 4. Then add both values, you get the value for Ixx. Similarly, we are going to find the moment of inertia about y-axis. Therefore, Iyy is equal to Iy1 plus Iy2. Iy1 is equal to Ig1 plus A1 h1 bar square. Here the Ig1, we are going to calculate the moment of inertia about y-axis. Therefore, remember that, what is the formula? 5g1 hb cube divided by 12. Okay, for hb cube 20 into 80 cube divided by 12 plus a1 value 1600 into, here h bar value is x bar minus x1. The value for x bar is 40 and x1 is 10. Same like that, find the moment of inertia about y axis for the component 2, second rectangular portion. Iyy is equal to ig2 plus a2 h2 bar square. ig2 formula is hb cube divided by 12 plus a2 value h2 into b2. h2 bar value is x bar minus x2. Okay, substitute the value and get the answer for iyy for component 2. Then the total iyy value for angle section is obtained by adding iyy for component 1 and iyy for component 2. Okay, then we are going to locate the principal axis. Okay, we know that the formula for the location of principal axis is tan 2 theta is equal to minus 2 ixy divided by ixx minus iyy. We already find all the values, product of inertia, moment of inertia about xx axis and yy axis. Substitute the value. We get the answer for tan 2 theta as 1.875. From that, 2 theta is equal to tan inverse 1.875. The value is 61.92. Then theta is equal to 61.92 divided by 2. The value is 30.96. Then locate the principal axis in the diagram. Okay, we have the angle section. Already we find out the centroid. From that centroid, you have to locate the UU axis and VV axis inclined at an angle 30.96 from X and Y. Okay, is it clear? You have to locate the axis UU and VV from the x-axis and y-axis, which is inclined at an angle of 30.96, that is the theta value. Then we want to find the principal moment of inertia I, UU and IBV. Okay, what is the formula for IUU? Ixx plus Iyy by 2 plus root of Ixx minus Iyy divided by 2 the whole square plus Ixy the whole square. We already find out all those values, substitute the value and get the answer for IUU. Then similarly IBV formula is Ixx plus Iyy by 2 minus root of Ixx minus Iyy by 2 the whole square plus Ixy the whole square. We already find out all the values, substitute the values and get the answer for IVV. Then finally we have to check whether the answer is correct or not. The check is Ixx plus Iyy value must be equal to IUU plus IVV value. Okay, already we find out Ixx, Iyy, IUU and IVV. Then check it. If both sides the values are equal, then your answer is right. If it is wrong, you have to recheck the each steps and find out the error. Then rectify it and complete the problem. Okay. I hope you understand the centroid moment of inertia, product of inertia and principal moment of inertia concept. Thank you, students.